I'm Madeline.
And I'm Zack. Probably put that together already.
A couple years ago, Zack and I collaborated on transforming an industrial robot into a personal back massager.
And the comfortable results of that have kept us collaborating ever since.
Today, we're going to talk about new work that we're doing called Robo-Op. And it's all about making industrial robots open for creative development. So today we're going to talk about some of the challenges when people start beginning to work creatively with industrial robotics, how Zack and I are overcoming these challenges, and how we hope to empower you all to overcome these as well. Currently, industrial robots are closed systems that are making a huge impact on the global workforce. You can see that over the past 5 years, there's been a really dramatic change of people moving out of the workforce and robots moving in and taking their place. And this is leading to sort of wide concern about what the workforce is going to look like in 2025. That the displacement that's happening with blue-collar jobs will move into white-collar, that unemployed will become unemployable, and that our education infrastructure is just not ready to come up with answers for these new definitions of work.
That's the people versus robots paradigm, industrial robots in particular. We're looking now towards the people plus robots paradigm. Plenty of examples happening in the open source community, some bottom-up models, some crowd-sourced funding models, art projects that engage people with industrial robots in social settings, and of course my favorite, gardening on other planets.
So despite the sort of changes that are happening, there are still steep challenges that impact people working at the fringes of industrial robotics. Perhaps the steepest is that they're still prohibitively expensive. All of these machines have proprietary interfaces, and currently the knowledge to begin to interact with them is still completely private.
So what we've tried to do with Robo-Op is tackle these things in a couple of different ways. They are prohibitively expensive, but the hardware that we've developed is modular and pretty easily reconfigured to adapt to different systems, including ones that have been decommissioned or replaced by newer ones that have a more accessible price line. Much friendlier software, which we'll explain a lot more about, but software that plays well with others and plays particularly well with software that already plays well with others. And then, of course, a knowledge hub, some place where we can share and hopefully get other people to adopt a sharing platform, because in our opinion, if you don't share it, it didn't happen. A couple of pretty simple motivations, and this is a little glimpse of the device itself on the end of a big robot. Here's a motivation. I'm not sure if you can make out that price line on the quote, but to extend sensing in the way that we might if we're doing some kind of creative application with an industrial robot, you have to invest in the US a mere $30,000 or so. So no big deal, right? Actually, it's a huge deal, especially for students. The other motivation was that in a student environment for creative projects, there's a tremendous amount of redundancy in workflows and in communication pipelines. Those are redundancies that can block a student from actually having the opportunity to do something creative and interesting and engage the idea part of their brain rather than just the technical. So what we set out to do was develop a universal tool adapter. And this process basically brought us a couple versions of a device that has a few simple things that help it interface with the robot. Interfacing with the robot, this is the device in kind of the clear plastic and it's encased electronics. Interfacing with the robot is an obvious first thing. It needs to work on the existing machine. We want to have access to our toys, and our toys are reprogrammable microcontrollers, which many of us use. We want to allow people to continue to install their own devices on the end of the robot in the same way they normally would. And we want people to be able to stick peripheral devices, attach things easily and quickly to the end of the robot without a lot of hassle. And create smart tools, essentially. We want people to be able to create smart tools and streamline the process of integrating them into robot control. To point out some of the features of the specific device, there's cross-brand mounting. What that means to us is any device can be attached in relationship to the end of the robot where all the magic happens in a meaningful way. There's signal transduction from the robot to the microcontroller and from the microcontroller back to the robot control system through a hardwire. There's also wireless serial, which lets us talk from a smart tool back to the control software. Generic power outlets, a really convenient thing when you're trying to plug in an IP webcam or a Kinect or a projector on the end of a robot. And then a custom mount that basically lets us use a connecting device that works across brands and across platforms and industrial robots.
So because you can never separate hardware from software with industrial robots, we also decided to find a way to sort of bypass all the proprietary software and interfaces that these machines use. So what we've done is we've created a little processing gateway to communicate with the robot. This helps us take something that was made for automation and make it ready for interaction. And what it also does is it takes this really arcane, proprietary closed language and makes it readable by humans and ports it to an open language. The other thing that we did with this is we connected it through other communication channels to communities and programs that are already ready for interaction, that already have people developing. So you can now connect through 4V, through processing, and use what you're good at in a different software environment to do something interactive with the robot.
Obviously, a big theme of the event here is that we wanted to share. It's pretty typical in the academic environment where we start that sharing can be cut off because it's sort of an arms race. We hope that by sharing a piece of technology that we use to play with these toys, that other places will be encouraged to share back, of course, and build some of the community. And, of course, we want to share a tool that lowers the barrier to entry of a pretty arcane system of hardware-software integration.
So we're hosting the project on GitHub. You can go to this long URL and find all the source code for the software and all the fabrication files for hardware. And what we're hoping is that people will begin to download, modify, and adapt and re-upload to the same repo all of their modifications for different robots. One thing that we need your help for, though, is to begin to configure this to other brands of robots. Ours currently works with ABB, but we want to open up other brands to have this sort of universal adapter kit.
It took one robotic back massage for Madeline and I to be convinced that the age of personal industrial robots could be a reality.
Is nigh.
It is nigh. The future is nigh, and it feels pretty good on the small of your back. In academia, we struggle with producing results that are scarcely relevant. And if they are relevant, they're often most relevant to closed proprietary systems. And in this environment, that's very, very closed. So seeing some of the transformative trends that we are in relationship to people's relationships to robotics, we really see this as more than just a streamlining tool for student projects. It's really an ethical issue of using open source to empower people to become more than just consumers of industrial robotic goods and services, but to become creators with industrial robots.
And with that, we just wanted to take time to say a special thanks to all the people that have made this project possible.
Lots of people involved, especially Mauricio Contreras, who's couldn't come with us this time, but he's our electronics engineer. We really couldn't do it without him.
And a special thank you to the ADA Initiative, who is the reason why Zack and I can share this project together on stage here today. They're doing amazing things to support women in open culture and technology, and you should help support them too.
Thank you.